This was always going to be a shorter lesson anyways. And as we get out of here at 1:09, we got a little 25 minutes or so to get this done. So the law of cosines, this is the same slide we had last time, so you don't need to copy all this down. The law of sines and the law of cosines are used to solve triangles that are not right triangles, otherwise known as oblique triangles. Okay? When we know these parts of a triangle, then we use the law of sines. When we know these parts of the triangle, then we use the law of cosines. Side, 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 side angle, side. Right? We're familiar with those acronyms anyways. Okay, these are the law of cosines. And it's given in two forms, and it's given solved for whichever is the thing you're solving for. So there's really only one formula here. So if we look at a triangle, let's label it like we label it. This is A, this is B, this is C. So this is little a, this is little b, and this is little c. Right, so in the standard form of the law of cosines, if you know B and C, sides B and C, and you know the angle that's in between them, which is A, then you can solve for the opposite side, A. Right, and these are just the other two. If you know A and sides A and C and the angle that's between them, then you can solve for the side which is across from it. So that's where the three versions come from. So this is the form that you use if what you know is side, angle, side. Okay, now if you take, for example, the first one and solve it for the cosine of A, right? Move these two, b squared plus c squared, to the left. Divide by negative 2bc. Multiply by negative 1. You get this. The cosine of A equals b squared plus c squared minus a squared over 2bc, which means you know A, B, and C, the sides, and you're solving for an angle. So this is the one you use when it's side, side, side. If you know all three sides, then you can find an angle. And again, it'll be different depending on which angle you're solving for, but if there's a pattern to it, I wouldn't get hung up about like you're memorizing all of these. Just remember that if you're solving for the angle A, then it's b squared plus c squared minus a squared. You know, these two match. These two are these two. Victoria? Good. Good. Tiana? Good. Okay. So in this first example, it's a side, side, side. Right? So here's the triangle, and the three sides are labeled. The question would be, well, does it matter which angle that I solve first? And the answer is, yeah, it does matter. There is a strategy to this, that if you know three sides, you want to find the biggest angle first, for reasons that will become clear later. Always find the biggest angle first. How do you know which is the biggest angle? Yeah, I mean, look at where's the biggest side? 19. So that's the biggest angle. Right? So in a side, side, side scenario, find the biggest side, and that's what you're going to solve for. And we'll do that on the next slide. So the main thing being find the biggest angle. Okay, so since we're going to find B, since we're finding B, we want this form, this one of the alternate form. Cosine of B equals. And we can plug in for the A, B, and C that we know. So cosine of B equals A squared plus C squared. 8 squared plus 14 squared minus 19 squared divided by 2 times 8 times 14. So you put that in the calculator. Make sure you use parentheses. Clear parentheses. 8 squared plus 14 squared minus 19 squared. And parenthesis divided by parenthesis 2 times 8 times 14. And I'm getting negative 0.4509. Okay, how do I find b if that's what the cosine of b equals? Do the cosine inverse, right? So second cosine inverse, second answer, 116.8. So b equals 116.8 degrees. So we can label that one right here. Okay, we still need to find two more angles. Okay, now because we found that angle, we actually know one side and opposite angle pair. So we could use the law of sines, and generally that's what we do. That's what the book does. So at this point, we would switch to the law of sines. This will be our side and opposite angle that we know, and then you're going to solve for either the angle C or the angle A. How about we solve for A, right? So with the law of sines, if I'm going to solve for the angle A, then I need to use this. Sine A over A and sine B over B. Okay, so we can plug in for what we know. Sine A over 8 equals sine 116.8 over 19. Right, so sine of A equals 8 times the sine of 116.8 divided by 19. So go ahead and put that in the calculator. 8 sine 116.8 divided by 19. 0.3758. So A equals the sine inverse 22.1. So how am I going to find the third angle? Law of sines, law of cosines. How about the law of 180? Right, subtract from 180. You don't need any more laws of anything. Just subtract 180 minus 116.8 minus 22.1. 41.1. I'm about to tell you that. 116.8 plus 22.1. So, if you're going to switch to the law of sines, remember the law of sines, sometimes in the solving of it, you could end up with two different triangles. And if you got two different triangles, one of them was going to have an acute angle at angle B, and one of them was going to have an obtuse angle at angle B. If you use the law of cosines to find the first angle, and you make sure it's the biggest angle, then if there is an obtuse angle, you would have found it. And then you wouldn't run into that problem when you start using the law of sines. You would only get one clear answer. You wouldn't have two answers to worry about. Because otherwise, we do need to worry about two angles when we do the law of sines. That's always a possibility. That's why the strategy is use the law of cosines to find the biggest angle, and then you won't have to worry about two triangles. Well, if that's the biggest angle, then there won't be an obtuse angle after it, right? So what would happen? Let's say that first we found this angle right there, 41.1, and then we tried to find that angle there. The first answer that we would get would be an acute angle. All right, and then so let's say you solved it like we would solve it, and you labeled all these parts. You would not have the biggest angle across from the biggest side and the smallest angle across from the smallest side. It wouldn't add up. So then you'd have to go ahead and go back and do the, okay, well then it's 180 minus that angle, it's obtuse, and follow it through, and then it would work. That's why it's always good to do a quick check and make sure, do we have the biggest angle across from the biggest side, smallest angle across from the smallest side? So, I mean, you could find anyone you want first. You will save yourself some potential problems if you find the biggest angle first with the law of cosine. Okay. So find the three angles of the triangle who have lengths 6, 8, and 12. A, B, C. A, B, C. A is 6. B is 8. C is 12. Okay, which angle should we find first? Right, across from the biggest side is the biggest angle. So we're going to find C first. So we're going to use the form of the law of cosines, solve for an angle. Cosine of C equals A squared plus B squared minus C squared over 2AB. Right, and so cosine of C equals A squared, 6 squared, plus 8 squared, minus 12 squared, divided by 2 times 6 times 8. Put that in the calculator, parentheses, 6 squared plus 8 squared, minus 12 squared, divided by parentheses, 2 times 6 times 8. Negative 0.4583. Well, remember, the cosine is negative in quadrant 2, right? So what that's telling you is that this is obtuse, right? It's not ambiguous here. If cosine is positive, you've got an acute angle. If cosine is negative, you have an obtuse angle. So the inverse cosine is 117.3. So we know that one. And then we could use the law of sines to find one of the two other angles. Is there any way that you could be given 3 sides of a triangle and then they don't make a triangle? What was the check in geometry to make sure that 3 sides did add up to a triangle? Yeah, you got to be able to add up the smallest 2 and have it be bigger than the biggest side. And so if you make yourself a triangle of side lengths 5, 10, and 20, and then try to do the law of cosines, you'll get the error. So it's possible to get no triangle with the law of cosines if it's the side, side, side. It's not possible with the side angle side. If you know 2 sides of a triangle of an angle and the angle in between, I mean, you can always find a line that connects them, always. So let's see, I'm going to find angle A. So this will be sine of A over 6 equals the sine of 117.3 over 12. So sine A equals 6 sine 117.3 over 12. Why is that on that? 6 sine 117.3 divided by 12. 0.4443. Second, sine inverse, 26.4. And then you could find angle B doing 180 minus. Okay. So that's side, side, side. Good. Good. Okay, here's a side angle side, right? Side, angle, side. Okay, there's no choice to make here. What are you going to be solving for first? You got to solve for the side, which is across from the included angle that you know, right? So you're using this form. Right? So go ahead and plug in for the things you know. A squared equals 9 squared plus 12 squared minus 2 times 9 times 12 times the cosine of 25 degrees. Okay, put that in the calculator. 9 squared plus 12 squared minus 2 times 9 times 12 times cosine 25. 29.24. And that's not A. That's a square. Now you got to take the square root. Second square root. 5.4. Okay, we still need to find two angles. So, but now, I mean, you can always use the law of cosines. If you like using the law of cosines, you could use it. It'll work. If you want to switch to the law of sines, you can do that because now we know one side and opposite angle. So how about we'll find C. So, and I'm just going to go straight to the formula. Sine of C divided by 12 equals the sine of 25 divided by 5.4. So sine C equals 12 sine 25 divided by 5.4. .9392. I'm just going to jump right to the C. Second sine inverse, second into 69.9. So that's C right here. And then you could use 180 minus to fill out the last one. Okay. I'm not going to go through that one just to save time. It's the same kind of deal. It's the side angle side. It'll work just the same way. There's no way that there's not a triangle with side angle side. So there's not that much informative to come out of it. So here's our real world problem here. Okay, the pitcher's mound on a women's softball field is 43 feet from home plate, and the distance between the bases is 60 feet. Okay, the pitcher's mound is not halfway in between home and second. Okay, how far is the pitcher's mound from first base? Okay, so they do have the corners labeled with capital letters, P, F, and H, and the opposite side with lowercase, P, F, and H. And we know two sides and the included angle. So how can we write the law of cosines? It's going to help us find that side. It's not A, B, and C. We're solving for H, so what is on the left? H squared, okay? H squared equals F squared plus P squared minus 2, I shouldn't have done that, edit, undo, 2F P cosine capital H, right? So it's the same pattern as we used with the A, B's, and C's. And now we can fill them in. H squared equals F 43 squared plus 60 squared minus 2 times 43 times 60 times cosine 45 degrees. So h squared equals 43 squared plus 60 squared minus 2 times 43 times 60 times cosine 45. 1800.3. It's 1800 feet from pitcher's mound to first base? What did I forget to do? Take the square root, 42.4 feet. And then last one. Last one. A ship travels 60 miles due east and then adjusts its course as shown. And after traveling 80 miles that direction, the ship is 139 miles away from its port of departure. Describe the bearing from point B to C. Okay? So the bearing, again, is with respect to a straight north-south line from B to C is going to be this angle right here. So what do we know? We know three sides. We need to find this angle B. And then how will we know the bearing? Subtract. If we know this whole angle, how do we know this angle? Subtract 90, right? So just we have these three sides, so we just need to use the law of cosines to find angle B first. So that'll be cosine of B equals, and I'm just going to go right away to the cosine of B equals a squared plus c squared minus 139 squared over 2 times 80 times 60. Oops, not squared. So put that in the calculator. 80 squared plus 60 squared minus 139 squared